On behalf of the NAMIC board, I'd like to acknowledge the lands we're meeting on and welcome you to the 2011 C2C Expo.
All right, I'm talking to Adut and Aaron from Temple Christian College. So, Adut, you want to tell us about your project here?
Well, we made a game for a blind lady at church, and then we decided to make a game for her because she asked us to.
So, do you want to show us the game?
So each time you press it, it makes a different sound, and then it gets faster and faster. And then when you lose, it stops.
So obviously a blind person can't see the lights, so they can hear the sounds.
Well, this is actually the breadboard that we made. It's like we designed it by ourselves. We needed something to work with, so we designed it. So this is like a mini computer chip right here.
So what do you think that you've learned from your experience in the C2C project?
Well, I've learned lots of stuff, like new things, like I've never soldered before, and then I learned new things, so yeah.
Well, I've learned that that we can do programming, soldering, wiring, building this fantastic game that we made, setting up the lights, putting chips in, like little computer chips to hold all our programming. So we learned a lot of things doing this.
Do you think that this is something you might take further into the future?
Yes, I believe I could, because I'm really loving tech. It's a good thing, it's good fun. I would recommend that somebody would give it a try. It's really good fun, and I'd probably have a career in doing this.
Excellent. Thanks, Adut and Aaron.
How did you become involved in the program? What did you have to do?
Well, basically we had to fill out an application form and just say what we wanted to do, why we should be the one chosen, and then they gave it to teachers and they decided who they want that was best for the job.
And what were the 4 jobs that were available that you could apply for?
There was the CAD team leader, the manufacturing team leader, the video team leader, and the design team leader, and one of those leaders would be the overall team leader.
What responsibilities did you take on to organise those teams that each of you were responsible for?
Well, for me, I was responsible for all the CAD stuff, so drawings and technical drawings, getting all the assembly aids ready, and then video team were doing video, putting that together, filming, manufacturing team thinking of ways to make our car better and to make it fast and perform it.
I was the video team leader, and we had to make a video that was sent off a week early, and so we filmed everybody and asked questions and interviewed them, and that's what I made. And also the responsibilities is that you have to stay after school and everything, put in lots of hours, lunch times, and work hard.
And what were some of the challenges with part of doing the design work for the car did you face?
Well, one of the challenges we come across was we actually lost one of the tapes with half of our filming on it, so we had to film all that stuff again, and it was really hard, but we can't overcome that. It's good.
And what worked really well overall with the presentation you've done today, the competition? What went really well?
Putting the car together, having everything set in the right place, that was really good for today. And then teamwork was a big thing for this. If without teamwork and the other members, it wouldn't have happened.
Yeah, lots of hard work and practicing it over and over and over again, getting better times, and the assembly aids really helped.
Have you got any ideas for next year? What changes could be made if you got a chance to do it again?
Changes probably would be the actual metal, the metal inside bit. We could probably change that to make it lighter or more efficient.
No, I thought it was pretty good.
Have you had a good time?
Definitely.
Yeah, definitely. Do it again anytime. Yep.
Can you tell us about your project?
It's a bag. You open it up and the lights open so that if you've got something in your bag that you can't find, you open the bag, the lights light up and you can find what's in your bag.
How did you come up with this idea?
We originally had another project that we were going to do, but then we had trouble and we thought of this one, and it's a great way of finding another way that things need to be improved.
What problems, if any, did you encounter?
Well, this morning we had one of the lights blew, so that just turned off one of the circuits, so we had to start soldering it and everything.
What have you learnt through C2C? What has it taught you?
That teamwork is a big thing, and if everyone doesn't come together as a team, then the final product of what you're trying to achieve won't come together successfully.
Hi girls. Now can you explain to us exactly what the project's designed to achieve?
Designed to achieve, so if you were to live on Mars, you'd have electricity on Mars, so that wind power, it will be changed to electricity, like exchange.
Okay, so we tested 2 different designs for our wind turbines. We first tested this one, but we found out that the wind had to be coming from on top for it to spin, and so we decided to use this one, which looks like this, so the wind can come from any direction and it'll spin from any way.
And have you tested it? Does it actually work?
Yeah, it actually works.
And how did you come up with the idea?
We did a brainstorming thing in class where we had to think of different designs and different things that happened on Mars, and then we thought that the wind is quite strong on Mars, so we have to use that to our advantage to maybe use the wind power to change to electricity or energy.
Now this was a team project, wasn't it? So how important was teamwork, and what did you learn about working in teams?
Teamwork was a big part of our thing, like all contributing to our design and all, so yeah.
And it was successful?
It was successful, it was fun, and it was like you learned a lot of different things on the way as well, so yeah.
Fantastic.
Okay girls, can you explain your project to me?
We basically did a night light that was for little kids with flashing lights and music, lullabies.
So how did you come up with the project idea?
At the very first stage of it, we had to come up with ideas of different things we could improve. And I just basically came up with the idea of a nightlight for kids with flashing lights.
Can you take me through some of the bits of your project here?
Basically, we only got around to the electronics side, so we have our fast-moving LEDs, our slow ones, and we have ones that you can use manually and you can change the colours. We were going to use an iPod through ours, but the program didn't want to work, so it was being mean. This was all touch, which doesn't like me. So they could pick their songs, play, pause. Most of the programming's here and it didn't want to work. And that was going to plug into our iPods and stuff. We never got around to building the cases because all the electronics took up most of the time. And basically it's all battery powered, so you don't have to run it on normal electricity.
Here we have a team from the Heights School, and we're going to ask them a few questions about their project, how it works and the problems and so on that they had. So guys, can you just explain and go through how you came up with this idea and how it works, please?
Okay, so basically this is a rubbish collection system. designed to go in a car, so this would go up the front of the car and this would go on the boot. We came up with this idea because in cars you usually get a lot of build-up of rubbish, and it's easier to just empty it if it's all in one spot, and so that it's collected all into one spot like a bin. And so basically how it works is this is a magnet switch, and as you open this, it turns on a motor at the back, and you put the rubbish down in the pipe and it gets sucked through to the back, where it can then all be collected. It just stays on for a few seconds after you open it to make sure that it gets sucked through.
Excellent. Can you actually tell us, as a team, as you worked on this project, what sort of problems did you have and how did you work as a team in overcoming them?
So when we started the project, we had a very big motor that was drawing a lot of current, which was a problem for us because it started burning all the wires, and when we used a power supply, it started having short circuits, which was so we tried to have thicker wires to stop the burning, but it didn't work. So we had to get a smaller motor to overcome this problem.
And were there any other problems that you came up with?
Yeah, the programming, we had a problem. The motor turned on at the wrong time. We fixed it. Yeah, that's all the problem. Yeah.
And guys, was doing the C2C program a valuable experience, working as a team? What are your thoughts on the whole experience?
Yeah, it was definitely a valuable experience, and it really helped with our team skills, being able to work in a team and be able to negotiate.
That's great, guys. It's a really good idea, and congratulations on getting it completed.
This year, you have entered the UAV Challenge competition. Could you, Lauren, please outline the project you have embarked upon?
As part of the UAV Challenge, we built a plane and a group to fly around a circuit and drop a 55-gram load onto a target using an onboard camera.
In achieving the project task, could you, Erin and Melina, who were both managers and team leaders, outline the organisation involved in managing the teams? I think, Melina, you're first.
Well, as our group was a really big group, it was really important that everybody had certain jobs. So we had like the pilot, the main engineer, person in charge of the drop mechanism, etc. So that everybody was on task and knew exactly what they had to do. And as being a big group, it also helped sometimes if someone wasn't able to attend the session because we had extra people who could fill in their jobs. So yeah.
Would you like to add on to that?
Also, for every group session that we did, we got a plan for each member at the beginning of the session, and at the end they were all collected so that we all knew exactly where everyone was at and how much progress had been made that day.
Liam, as a safety officer, what procedures were necessary for you to ensure that the plane was safe when it was in the air and also when it came down?
Well, to ensure, of course, safety is the number one priority for this project. And for everyone to be safe, we had a number of safety procedures in order to ensure that the plane safely took off and landed and was safe during maintenance. To do this, we did pre-flight checks involving the wings to make sure it was all in place and the batteries being connected properly. And all the apparatus that was put onto the plane was first tested for safety to make sure it wouldn't fall off and hurt someone.
Harry, who is a bit of a reluctant speaker, was responsible for the maintenance of the aircraft and a lot of repair work, as well as modifications. Harry, would you like to talk about your experiences with the plane, please?
Well, just with general flying, there's general breakages as well, like crashing into the ground and all sorts of repairs that need to be done. There's also systems like camera and drop mechanisms that need to be improvised and manufactured to fit the plane as well to make it go to its regular performance and that. So that was good.
Could you please outline the experiences of the UAV Challenge both at Edinburgh and also throughout the year?
Okay, well, at Edinburgh, it was a very interesting experience. When we first arrived, it was very professional, everything was set up, and it was a really good day. We got to interact with other schools, see what they did differently to us, and actually doing it in school. It was very, it's like, we got to put what we learned in our lessons into like practice. We got to maths and physics and technology, and it was a good team group building exercise.
Ruben, you were a bit late coming into the flying team, and you've obviously seen some of the crashes, etc., that occurred and the successes. Would you like to have a talk, please, about what experiences you shared while flying the aircraft?
We learned quite a lot from the experiences. We crashed quite a lot because of lack of experience from the pilots. But over time, when we used the flight simulator, we did show up pretty good at the end, I guess. So.
Lauren, would you like to sum up and talk about your overall experience about it?
Well, I guess overall the year has provided lots of challenges and obstacles for our team. We have learnt to deal with them as a group, and it's a fantastic experience. We learnt how to cooperate with each other, problem solving, working in a team, and along with having a brilliant time as well.
G'day, I'm David Paul. I'm the biology teacher at Tyndale Christian School at Salisbury East, and these are a couple of my students, Samantha and Zia. Okay, Sam, can you tell us about this project I got you to do?
Okay, so the EWB, the Engineers Without Borders, we looked at poor people in like a village in India and how we could help them and different aspects of that. And so what we did is design a house and put 4 families in the house and just gave them the essential things that they would need and stuff to improve their quality of life and help them out with that. So.
Sure. So, Zia, where'd you get your information from to sort of understand what it was like to live in India?
On the EWB website, there was a list of problems. So, like Sam said, we chose housing, and it gave us a report by the government in the little town. And so we looked at the issues that the houses were faced with there, so like heat, intolerance, and bad weather and stuff like that. And yeah, so we just got most of our information off the report.
Can you just explain, maybe with the map, how you designed the house for that particular location in southern India and this poor village? Why did you use the materials you did, and why did you arrange it like you did?
Well, we tried to get the easiest layout so that each family would have their own little corners, but they're all still a community kind of house. On the report, it gave a list of materials that were cheap, durable, and efficient. So I looked at all of those, and I found the 5 best ones that would work. Yeah.
And what were they? Can you just point them out, maybe?
Over here, that's compressed and stabilised earth blocks for the walls, also mixed with rammed earth walls, bamboo, palm, Mirafo cement roofing, so that would be a shelter for the families, bamboo reinforced concrete, which would help the walls be stronger, and vinyl flooring, which is really durable and easy to clean.
Okay, Sam, what was your part of the project? Because you all did different parts, didn't you?
Yeah. So furniture, we kind of looked at, because each of the families had a bedroom, and so we looked at bunk beds and for the kids, and just different appliances for them, and we worked out like the average costs of them. So, and we made it affordable, so it would be the appropriate cost for them, so nothing too expensive.
Now, what did you most enjoy about this project? What did you get out of this, or what made you feel good?
Seeing how a house can help out so many people, and because it's 4 families, just how something as simple as just putting all this together can help so many people and just improve their quality of life. So
fantastic. How about you, Zia?
Yeah, same thing. The idea of helping people living on the streets and giving them a shelter over their head is really heartwarming.
What was the aim of the Year 9 Stellar project?
It was to create a model of a wind turbine and to be the most efficient it could possibly be. So what we have here now is our wind turbine. It is being powered by the fan because obviously there's no wind in here. It is on some leads that connect so we can measure the voltage and the amp. It's then also connected to the power board, so we could then power the little fan, the lights, or the buzzer.
How did the project link across science, maths and technology?
In science, we tested out the length and the how many
blades that we would need to use. In maths, we added all the results together, and then in technology, we created our wind turbine.
What process did you follow to build your wind turbine?
We follow the process of using information in science and then creating it in technology, and using also the Stellar books for a guideline as well.
Where has this project taken you and your team members to connect with the community?
It's taken us to the Starfish wind farm, where we had a tour that showed us the wind turbines, and then it also took us to Adelaide University, where we tested our wind turbines on their wind tunnel.
Have there been any awards given?
Yes, one of our team members, Sophia, she won a certificate from the Adelaide University for her wind turbine was the most efficient out of all of ours.
And how has this made you more interested in math, science or technology?
It showed us all the different things that we could use in science, maths and technology. Like, it's not just a basic sort of outline, it can range from lots of different aspects.
Do you think Hamilton and other schools should have more inquiry-based, hands-on, cross-curricular projects?
Yes, definitely, because I find it very interesting and it was really fun.
It's great to be back again this year. I think there are 26 schools in the program and more than 3,000 students. We have today 500 who've been selected to put their projects on show, and I have to say I'm incredibly impressed. I think this is my 4th year, and every year the programs get better. This year we see an element of sustainability, the environment, and also programs that look at helping